Hi, this is section 2.5, linear functions and models. I am not going to have a very long lecture on this section simply because it is stuff you have seen before. So I'm just going to make the connections to the terminology to something we've seen before so you can see that, oh, this isn't all that difficult. This is stuff I've dealt with in the past. I can handle this. So it's like linear functions. Wow, that sounds very intense. So first of all, the definition. A linear function is a function, okay? A linear function is a function, makes sense, of the form f of x equals ax plus b. The graph of a linear function is a line with a slope of a and a y-intercept of b. This is just a very fancy way of saying y equals mx plus b. Instead of the y, we have the function notation, f of x, f acting on a variable, which we like to use x as our variable. M, which stood for slope before, is now just replaced with the letter a. And then we have that x plus b. So this straight line that you have learned about a long time is now just going to be made a little bit more complicated, a little bit more sophisticated with function notation, function names. Okay. Some things we want to make sure we understand. Linear means straight line. So that means we have it in this form, this mx plus b, or this ax plus b, whatever letters you want to use. We should be able to look at different situations and say, is that a linear function or not? So we want to look at these. Are these linear functions? That's the first thing we want to do. So we're going to start seeing some of these written in different forms. So first of all, let's look at f of x equaling 7 minus 2x. Does that represent a linear function? In other words, is it of the form ax plus b? Can I write it that way? So I'm giving you a pause thinking, can you write this 7 minus 2x as an ax plus b? So you could pick out the a, you could pick out the b. The answer to that is yes, by simply changing the order. Remembering we can change how things are written in order. So negative 2x plus 7, there it is. The negative 2 would be our a, that's our slope, y-intercept 7. So the answer to that is yes. How about this one? Let's call it a different letter. Call it G. We don't always have to have F. We could have G. And we could have something that looks, a little bit more complicated. X plus 1 over 5. Is that a linear function? Can I write this in the form ax plus b or mx plus b if you like that better? The answer to that is yes. Okay, because I can write this as x over 5 plus 1 over 5. So I can break up that complex, ugly-looking fraction, and then I can rewrite this x over 5 as 1/5 x plus 1/5. So yes, we can, if we really want to write it in that specific form, yes we can. Our slope would be 1/5, y-intercept would be 1/5. We'll do one more here. Well, maybe we'll do a couple. X cubed plus 7x. Is that a linear function? Can I write it as ax plus b, where a and b are numbers only? They do not have other variables in there. A and b are numbers, not letters or variables. This one is not a linear function because we have a cubed in there. If we have higher powers of x, it will not be a linear function. F, G, H, let's go with K. I know I didn't stick with all the letters. 2x minus 3 all over x. This one we could try to start, like we did the one before, previous one. We could write this as 2x over x minus 3 over x, which I could write as, well, that would just be 2. And then I could write this as 3x to the negative first power. But again, this is not a linear function, because a linear function has to have an x to the first power. So that one is also no. Okay. I'm not going to go through and actually graph a linear function. We've done that in past videos. Earlier in chapter 1, I believe, we talked about straight lines, how to graph them, how to get the slope. We've done point slope, slope intercept, all of those things. So I'm not going to go through that again. The one thing I am going to do is bring back what we learned in 2.4 and put it into 2.5. So I'm going to write this down, and then it'll make perfect sense for the linear equation or linear function. And the linear function does look like f of x ax plus b. Whoops, forgot my plus sign in there. So, or mx plus b if you like that as well. The average rate of change of f over any two values, or between any two values, is the slope of the line. Which means it is a. Which is going to be your coefficient on front of the x. The coefficient on the x term. And we can do this in general if we want to. But what I'm going to do is I'm going to actually just use a picture. I want you to think about the average rate of change. So here's a point. I'm going to call it x1. And here's another point, x2. And we have a linear function between these 2 points, which means we have a straight line with a slope equal to a. So here's my straight line. And the slope of this line is a. Okay? Average rate of change represents the change in the y value over the change in the x value over that region, or the slope of the line connecting those two. So of course, if you have a straight line, the rate of change will be the slope of that straight line. And if you look back to the example we did at the end of the 2.4 video, I did the equation, or finding the average rate of change of a straight line, and it did turn out to be that slope of that line, because the average rate of the change in a function is the slope of the line connecting the 2 points. If we have a curve, it's going to be different than if it is a straight line. So just kind of keep that in mind. So you don't have to go through all the work. You don't have to go through that f of b minus f of a over b minus a formula for that average rate of change. Because it is the change in your y over the change in the x. It is the slope of that piece from here to here. And in a straight line, it's going to be the slope of that line, which is that a value. Hopefully that makes sense. Hopefully you found this video useful. Again, I did make it somewhat short because linear functions are nothing more than straight lines, and you have seen straight lines for many years.